This video demos how the sample logistics facility locations uploaded to the Geo-TIDE tool in the previous video can be analyzed with public layers to enhance fleet electrification planning. I'll start by adding the U.S. highway network freight flows, along with the corridors being targeted for government-funded heavy-duty vehicle infrastructure projects. 3 of the logistics facilities are along the Midwest ZEV corridor shown in purple, which is being targeted for medium and heavy-duty EV charging and hydrogen refueling. All else equal, it probably makes sense to prioritize early fleet electrification efforts along this corridor to take advantage of this public infrastructure once it's installed. Of the 4 states with logistics facilities, the estimated total cost of truck ownership is lowest in Illinois, thanks to low historical electricity prices and demand charges in that state. In our case, we actually have info about average electricity rates at each facility, which show the lowest rates at facilities near Chicago and Columbus. The grid emission intensity is also relatively low in Illinois, resulting in lower estimated life cycle emissions for an EV truck operating in the state. We can also check where there are existing DC fast chargers. While most of these are only suitable for light-duty vehicles, it can still give an idea of where there's existing support and precedent for vehicle electrification. We see a lot of chargers in the Chicago area, suggesting this could be a relatively supportive area for fleet electrification. Looking at the stops per day, we see that trucks operating out of the facilities near Chicago, Detroit, and Effingham return to their facilities around 3.5 to 4 times a day, implying regular out-and-back trips from these facilities. Trucks spend around 2.5 hours stopped at the Chicago and Detroit facilities on average, and only travel around 70 to 100 miles before returning to these facilities. These short, regular out-and-back trips and long stops could make these facilities well-suited to install any needed charging infrastructure. Assuming we use about 2 kilowatt-hours of battery energy per mile based on the Tesla Semi performance, this means each trip from these facilities drains about 140 to 200 kilowatt-hours of battery energy. If trucks can be charging for most of the 2.5 hours they're stopped at these facilities, that means we can comfortably rely on 200 kilowatt chargers, with the possibility for trucks operating out of the Chicago facility to top up with public charging along the Midwest corridor once it's installed. Looking back at the total cost of truck ownership, if we modify our maximum charging power to 200 kilowatts and assume our trucks are getting high utilization, we can get our cost premium relative to diesel down to 15% in Illinois and 20% in Michigan. Looking at the cost of ownership breakdown for trucks operating out of the Chicago facility, by far the biggest difference comes from the higher capital cost of buying an EV truck. From the electricity cost breakdown shown over a 10-year truck ownership period, almost half comes from the capital cost of installing the charging infrastructure. So, if we can leverage incentives to meaningfully reduce some of these capital costs, there's already a possibility to get to cost parity with diesel. Assuming we can take advantage of federal EV truck purchase tax credits of $40,000 from the IRA, this can already reduce the truck purchase cost by 15% from the $280,000 purchase cost assumed in our model. We can then use the tool to see what other incentives are available at the state level. On the Geo-TIDE tool, I'll bring up the Incentives and Regulations layer and filter for incentives targeting fleet electrification. I can then use the click feature to dig into what's available in Illinois. The Illinois EPA offers grants of $70 million to support charging infrastructure development, prioritizing medium and heavy-duty vehicle charging. There's also potential support for purchases of EVs and charging infrastructure through the Illinois Science and Energy Innovation Trust. While the details of these funding sources would need to be investigated, there does seem to be a possibility to bring costs down near diesel parity through a combination of state and federal incentives. Okay, so to recap, overlaying our sample facility locations and data on the Geo-TIDE tool has allowed us to combine our facility-specific info with various public layers to identify regional operations based out of the facilities near Chicago and Detroit as potential early targets for fleet electrification. This was thanks first to their proximity to the planned Midwest heavy-duty vehicle infrastructure corridor, second, their relatively low total cost of ownership and emissions, and third, the potential for trucks to charge at these facilities thanks to low range requirements and lots of time spent at the facility. At the Chicago facility, we also saw encouraging precedent for vehicle electrification projects in the region. Lastly, our costing analysis at the Chicago facility showed potential to bring total cost of truck ownership near diesel parity with federal and state incentives. Thanks for listening, and feel free to reach out to us if you'd like to explore how you can leverage the tool for your transition planning. We'd love to hear from you.